Alhamdulillahi Rabbil Alameen wassalatu wassalamu ala Rasulillah. In this video I'm going to explain how to find the domain and range from a graph. I'm going to give you two methods for finding the domain and range from the graph. See which method is better for you and you could stick for that method. So let's take this example. We have this graph. I want to find the domain. First, let's start with the domain. One of the methods uses the vertical line test. We know that the vertical line test shows us whether this graph is a function or not. But again, also we can use the vertical line to test the bounds of the graph for the domain. So we always start from the leftmost end point of the graph. We know that this graph is going downwards and to the left unbound. So somewhere here it goes to infinity on the x-axis. So we start with our vertical line test from the leftmost, which is negative infinity. So this is our vertical line. And we know that it is touching the graph at some point down there because this grows unbound. And we keep on moving this vertical line test to the right. As you move it to the right and you know that it still touches, so you keep moving it again and again. So you know it still touches because this is growing unbound to the left and at the bottom, so it will touch this graph somewhere in the bottom. I will keep moving it and I know it is still touching. Keep moving to the right as long as it is touching. Keep moving to the right as long as you know it is touching the graph until you come to a point where after that point, if you move your vertical line, you will no longer touch the graph, which is this point. Okay, if I move to the right again, I will no longer be touching the graph. So I know I have to stop. So now we have two endpoints. One which is negative infinity because our vertical line started from the negative infinity. And the last point which is on the right is number 3 because this is 1, 2, 3. So I'm ending at 3. Since this point is being like, it's not an open point, it's a closed point, I know that 3 is included. Because 3 is included, I need to write it in interval notation as a square bracket. So my domain will be open bracket, negative infinity, okay, 3, and square bracket. So that's my domain. This is one method to find the domain. The other method to find the domain would be to look at the graph and project every point of the graph onto the x-axis. So if I project every point to the x-axis, okay, I'm projecting every point from the graph to the x-axis, and you can see how am I doing it. I'm taking the point and vertically projecting it to the x-axis. So if you just could visualize this, you are projecting every point from the graph onto the x-axis, and you can see that all the points that are included for the domain. So I'm projecting it onto the graph. Now, there is no more points to be projected. Of course, over here, every point will be projected because your graph is going to the left unbounded. So all these points are included. So as you can see, every point here on the x-axis is included until the point number 3. Again, this shows us that the domain is from negative infinity to positive 3 and 3 is included. Let's move now to the range. How to find the range? To find the range, we do now the opposite kind of work. So instead of the vertical line, we could use the horizontal line test. We know that the horizontal line test shows us whether the function is a one-to-one or not, but also we could use the horizontal line test to determine the range of the graph. Again, so I will use the most bottom or bottom end point in the graph, which is negative infinity. So I'm starting from the bottom. This is my straight line, of course, just imagine it to be a straight line. So this is my straight horizontal line, and I know it is touching the graph somewhere in the bottom, so from negative infinity. As I move there, this line, I know that it keeps touching the graph, so I'm moving my horizontal line, and I know it is touching because it's touching here. So it's, as long as it keeps touching, I will keep on moving my horizontal line, even if it touches on more than one point, which, for example, in this instance, it's touching on 2 points. Even if it's the case, I keep on moving it because it is touching. As long as it is touching, I keep moving my horizontal line. Again, here in this instance, it touches on 3 points. It doesn't matter. As long as it's touching this graph, I keep on moving my horizontal line up and keep on doing this until I reach a point where if I move further, the horizontal line will never touch the graph again. And this is at this point, or this point, doesn't matter, because that's on the same level, so which is here. So if we count 1, 2, so it stops at 2. So we know that it went from negative infinity until 2. Now we know that our range will be from negative infinity, we open a bracket, until number 2. And we know that 2 is included because here it is closed. It's not an open circuit. Or this one, not an open circle. So we do a square bracket. So we know that this is the range. Again, the other method is similar to the domain thing, but we project the points onto the y-axis instead of the x-axis. So if we do it again, so we raise the pen, and let's project the points, all the points onto the y-axis. So I'm projecting all the points onto the y-axis. I know that as long as you project it and it comes to the y-axis, then everything is part of it. It suffices to do on the left side, because even if you do on the right side, you come to the same points here. Okay. So if we move, we know that the last thing projected onto the y-axis is at 2. So if you look at it, your y-axis is covered from negative infinity because all these points have been projected on the y-axis, all of these points, until 2. So you see, now my red line on the y-axis is this, from negative infinity to plus 2. So my range is negative infinity to plus 2, until plus 2. So it is negative infinity and everything in between until we reach the point number 2, and with closed square bracket because 2 is included. So I hope this helps you in the future to find the domain and range. We could take another example. So it asks us now to use the graph of f to find the domain and range of the function. In order to find the domain and range of this function, I need to move let's start with the domain. I need to move my vertical line from the most left end point. Okay, so my most left end point would be this one on the graph. And I draw my vertical line. So this is my vertical line. And then I keep moving it to the right. So I always keep moving my vertical line to the right in order to determine the domain. As long as it touches the graph, I keep moving it to the right. Now, one thing you need to notice that I started at this point because this is left hand point, and this would be 1, 2, 3, so that's negative 3. And because it's a open circle, this means the negative 3 is not included. So my domain should start with negative 3 and with an open bracket, not a square bracket. Now, if I keep moving my vertical line test to the right, I come to a point where it is touching the graph at 2 points. It doesn't matter as long as it is touching. Now bear in mind that it's touching at a closed circle over here, which is number 1, and at an open circle, which means this point is not included, which is again number 1. So what should I do? Should I include number 1 or should I not include number 1? Since one of the points touches this vertical line, which is this one, this means I need to include number 1. I need to include it. You don't include it only in the case when the open circle is the only one which is touching the vertical line, which is like this one. But if it happens that you have one or more closed points on the same level, then yes, you include the point. So now number 1 is included. But still, I did not finish. My line, if I move it to the right, I will still be touching the graph. So let's move our vertical line further. And as I move it further to the right, I know that it keeps touching the graph at some point. And I will keep on moving it to the right. And because this is unbound to the right, this is the arrow, it is unbound to the right, means I will go to the infinity and still my vertical line will be touching the graph. So I move from -3 until infinity, and I didn't stop there. So my domain would be from -3 until positive infinity, but positive infinity is not included. So now let's take the range. So what is our range? I will use the second method to know the range. Of course, you could use the first method also, but I'll use the second method. So I'll project all my points onto the y-axis. So I'm going to project this onto the y-axis. Okay, so I projected all my points to the y-axis. So my range would be from this point, but okay, so let me just use the eraser. Okay, so my range should start from this point, but not including this point, because this is an open circle. And I will color now the y-axis. I will color every point where it has been projected on. So I'm coloring my y-axis, and also I'm coloring this point because it's projected on this point. Okay, so what does that mean? It means I have two sections of the range. The section which starts with this open circle and down to -infinity, and the section which has only this point on my y-axis. So my range will be, of course, we always start from the bottom to top for the range. So it will be from -infinity, and of course with an open bracket, because infinities are not defined. So from -infinity until this point, which is -1. So that's -1. But -1 is not included, so it should be again an open bracket. And that will be union, because we are having another section. So I need to put a union to include the other section, and the other section is only number 1. So number 1 is included, so I'll do a square bracket for number 1 and close it with a square bracket. So that will be my range, -infinity to -1 union number 1. And my domain, I said, is from -3 until positive infinity. Okay, so that's my domain. So as you see, it's it's letter B as an answer. Domain -3 to infinity, and range -infinity to -1 union 1. Hope this helps, and have a nice day.